So, machine learning models only learn what data shows them. If the data is noisy, biased, mislabeled, or unrepresentative of real use, the model will memorize shortcut of the field in the it will give you, let's see, rubbish data, rubbish result. So high quality clean images or clean data, correct labels, balanced classes, diverse conditions, like for instance in object detection, lighting, pose, and backgrounds, directly improves generalization, stability, and fairness, often more than extra model complexity. So it's not needed to use a complex model to get, let's say, fantastic results. So the data is the more important. It's the most, or let's say, the heart of the machine learning. So equally important is how we split the data into train, validation, and test set. A clean split give an honest estimate of the performance and also prevents data leakage. So in a computer vision or machine learning on any field, leakage is a common when near, let's say, duplicate frames or maybe a duplicated data. So in this video, we will try to see what are the scenarios of splitting the data into train, validation, and test set. I will go through this and we will see how some questions are coming. If you are expert, I mean, if you have, let's see, have experience and the position is high, for instance, or they have several experience, you will not be asked such questions. But just for the beginners, so what are the train and test? So the training test is the data that will be used to teach the model. And the model will extract, let's say, the patterns and relationship from this data. And finally, this model, we will test this model using another data, which is unseen data. So please remember this. You have test data, you have training data, and test data. The test data will not be seen, will not be seen, will not be see. Let's see, the model will not see the data, the test data during the training, and it's like studying for an exam with practical questions. This, let's see, consider as a training. And when you decide to not decide when you're taking the exam, real test, this is the testing. It will test, the teacher will test your let's see studying, or let's see the training, right? So this, we split the data into train and model. Now, why we need to split data into train and test data? So if I meet someone, let's say, great, let's say, as memorizing, but he can't solve any new problems. Sometimes you have, let's say, you can solve this specific problem, but if someone change it a little bit, adding some variables or maybe something like this, someone will not be able to, let's see, solve this issue. That's what happened when we don't split our data set into training and test. So if we test our model on the same data, so imagine that you are training your model with one data, right? And you test with the same data it learns from. It's like letting a student create their own test. So they will get perfect every time, but they will haven't really learned. So splitting this data is trying to prevent, let's see, cheating, and also show if your model can handle new situations like predicting an apple price for varieties and it hasn't seen before. So training and testing on the same data is cheating. So you have to split data into tests. So tests act as unseen data to evaluate real performance, and will also help identify if model is truly learn patterns or just memorize it. So this is keep in mind. So testing on unseen data is a true measure of model usefulness. So how do we typically split the data? So a standard is 80-20 training and testing, and or maybe 70-30. But the advanced way is to split your data into train, validation, and test. So this is the optimal way I would see to split it into training, validation, and test. This can be 70, 50, 50. And this question here, why we need a validation test and why it's used. So a validation test is a portion of data that can tune a model parameters during the development. If you are expert with, let's see, CNN and or maybe deep learning, and you have in the beginning we have forward propagation. Now, for the back propagation, we need to update the parameters. We update the parameters of the training model based on validation. If the model is, let's say, working better on the data, on the, on the, let's see if the model is predicting the correct result on the validating set, it will be okay. If not, we will try to update or let's see tune the parameters. And also it's compare model to select best performance. But let's say remember this validation set is like practice test before the final exam. So just keep it simple. So sometimes you're studying for this test and you have some, let's see, set of previous last year's exams, and you will try to prepare training study and test yourself before the final exam, let's see. And this validation set is really important for the deep learning. So what is the limitation of train, validation, and test? It's sometimes overfitting, underfitting, and also randomness. So sometimes you split the data into different results. So, so the important, let's say, note is that each set each set have to be are coming from the same distribution. For instance, if you are training on detecting cars, the validation and also test have to have, let's see, cars. If you have training on detecting bottles and the validation has no buttons, this we will have overfitting and also maybe underfitting. So a better technique is to use cross validation. Is use multiple train test split for more reliable evaluation. If you would like to evaluate correctly your model, you have to use cross validation. And remember, finding the right balance between the simplicity and complexity is the key. I think that's it for today. And if you have any question, just drop it down in the comment below. I will definitely answer it. Thank you again.